Good afternoon, students. I welcome you all for this recorded video session for the unit number 3. So today, I'm going to explain you about the new topic and innovative topic called as elliptical curve cryptography. So in this particular unit, we have come across some various algorithms responsible for this key exchange. So before let me go into this particular topic. Let me then explain you what is meant by this key exchange algorithm. That is, we might have come across various public key cryptographies like RSA algorithm and similarly a number of algorithms are there. But among these algorithms, one major concept is we have to, the authorized sender has to share the corresponding key which has been used for encryption and decryption process. So this particular key may be used uh, directly and indirectly for the encryption and decryption process. So I hope you understand what is meant by this public key cryptography. Public key cryptography in the sense, let me explain you with the diagram that is, uh, here two parties will be agreed to perform some certain security communication and both the parties will be having two separate keys here. Suppose consider this is a party A and this is a party B. A will be having two keys and similarly B will also be having two keys. What are those two keys and what is the use of those keys means these two keys involves one is private key for party A and party B respectively and similarly public key for party A and party B. And as I mentioned earlier during the live classes that this private key has been selected randomly as per the choice of the individual parties. That is, it may be party A or party B, whatever it may be. They can choose their own private key, and this private key is not will not be shared to the other parties, even it is an authorized sender or the authorized receiver. Then for what else we have been using this private key in the sense, we had mentioned that here we are having two keys, one is called as private, another one is called as public key. Apart from these two keys, these two parties will be using another key called as secured key and this private key is used to generate this particular secured key which will not be shared to others but it will be generated by its own sender as well as the authorized receiver. So let me come back to the private key. This private key is, has been selected by this individual users and as I mentioned earlier during the live sessions, it is advisable that to select a private key in a prime number. That too, it will be advisable that if the key is nothing but a numerical value, and this numerical value may be a prime number, and it is well and good if it is a biggest prime number, so that the hackers or else the cryptanalyst persons will feel hard to break the key which has been acquired illegally or brute forcingly. So we are going to mention here that is when we are sharing this public key, I mean this public key will be made known to all. That is, every person in the group or in a cluster will be aware of each and everyone's public key because public key has been made as known to each and every person. So this hackers or the cryptanalysts may tend to use this particular public key to acquire certain information on your private key as well as your secret key that has been used for encryption and decryption process. So this unit deals with how do we transfer the key secretly, that is called as key distribution algorithm. So in the previous recorded video session, we had discussed about Diffie-Hellman key exchange algorithm. Hope you all downloaded it and visualized it. That is, there in the Diffie-Hellman key exchange algorithm, uh, the public key has been shared to all, and similarly, this public key is used to generate the secret key, which has been used for encryption as well as decryption process. Remember that the public key of both the parties are not same, it is different, but still the key generated, secret key generated will be the same, which has been generated using this public key. So now, this particular elliptical curve cryptography is one kind of key exchange protocol that is coming under this public key crypto systems. So, why we are going to this elliptical curve cryptography? Let me answer for this particular question that even because we are having some other previous very good algorithms like RSA algorithm, RSA algorithm, and then some symmetric key cryptography algorithms like this. N number of algorithms has been evolved and that has been proved to be more secure. But still, why we are using this stepping into this elliptical curve cryptography designs? Uh, just look at this particular comparison table, comparison of key size. That is, as of now, we know that RSA algorithm is a highly secure algorithm with various key size. So suppose in an RSA algorithm, if I am using 1024 bits as a key size means to generate a particular standard of security means in the ECC, I mean elliptical curve cryptography, I just need 160 bits of key size is enough. So just compare the key size of this RSA algorithm and this elliptical curve cryptography algorithm. Comparatively, we can able to observe that. Look at this one. Excuse me. Comparatively, look at this one. Here it is 1024. Here it's 160. So just come. If we are performing the ratio of this key means what is this ratio of this key? So that is just divide this 1024 with 160. That is, let me use the pen. So if you are comparing these two RSA algorithm with respective to ECC means, so that is one 1024 with respective 160. I mean 160 is the key size of this elliptical curve cryptography. 160 which will be equal to 6.4, which means we can tell that this elliptical curve cryptography can able to provide a high level of security which the RSA has been providing with a minimal minimized key size. So just come and then this is six. This particular ECC algorithm can able to provide a security standard with 6.4 percentage reduced key size. And similarly, divide this one. The key ratio will be 2048. I mean 2048 divided by 224. The ratio turns up to 9%. So the elliptical curve cryptography here has been reduced up to 9% here. And similarly here, this will be extending up to 12%. So likewise, as far as its key size is compared with the existing RSA algorithm, we can tell that the elliptical curve cryptography is having a a minimum number of key size to provide a high level of security. So here we will be having a doubt that what is that in a key size. So if the key size is bigger means surely it will lead to a high level of security. So what is the need to prefer a minimum minimum bits as a key size? The thing is, if I am using a maximum number of bits, I repeat, if I am considering a biggest key for this encryption and decryption process means will be more. I mean, the processing time for this encryption and processing time for this decryption will be very more, so that the data transmission will be very slow. Whereas in this ECC, I mean elliptical curve cryptography, the same level of standard has been maintained, but with a minimum number of keys. So of course, when we are comparing this RSA and ECC algorithm, we can tell that this ECC is the most efficient one.